All right, so now we're going to talk about alkynes being reduced to alkanes, and we're even going to find that we can reduce them to alkenes. All right, so just like we did, remember this reaction from alkenes? So just like we did with alkenes, let me go to a different color. Just like we did with that, we can take, if we have enough hydrogen, it's going to take two equivalents, right? If we take enough, because one equivalent, we just make it an alkene, right? If we take two equivalents of hydrogen, we can go to an alkane all the way, all right? What we can't do, though, is we can't stop at this point, right? Because the first one goes to an alkene, but this is actually faster, or rather, this reaction is faster, right? So it turns out that if you have one, if you just put less hydrogen in there, then you're really going to get a mixture of products because you can't stop this, right? So if these two are competing for a hydrogen molecule, these two, if the alkyne and the alkene are competing, the alkene actually wins. So anyway, the point is, if you want to, that's a little subtle technicality, but here's the point: you can't stop. If you treat H2, or rather an alkyne with H2 and platinum, it's going to go all the way to the alkane. All right. So there have been some clever ways of devised to get it to the point where it can stop. We can take H2 with a different kind of catalyst, all right, which we're going to call a poison catalyst, and we can make it so in the poison catalyst, this does not do anything here. It won't reduce a double bond. So with Lindlar's catalyst, then we're going to get a cis addition of the hydrogens. That's what that's about. So Lindlar's catalyst looks like this. I know, it's a big mess. When I'm handwriting this for a test, which I won't be handwriting it for yours, right, because we're not doing a handwritten test, but I'm handwriting it, I'll just do like Lindlar's catalyst, H2 and Lindlar's catalyst. So either way, just be comfortable with that. If you see this, you've got to recognize it as Lindlar's catalyst, right? That would be a fair question. Another fair way to do that would be, you can see this would be complicated. Boom, 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 boom. In palladium and barium sulfate, right? And methanol, right? And methanol and H2, right? What a mess. Okay, you can see why I would prefer just to put Lindlar's catalyst, but either way, you got to be prepared for that either way. Let's move on. Okay, the reason why I sort of intimated in a previous slide, the reason why it doesn't go all the way, it stops at the alkene, is because this second step is not catalyzed, right? So you start out with the energy of the alkyne is, relatively low, right? If you don't catalyze it, then the energy of the intermediate is super high, right? But if you do catalyze it, it's brought down here, way much lower. So this brings us into the range of accessibility to us, right? And so the energy of the alkene is lower, right? Which is what we would expect. But Lindlar's catalyst will not catalyze the second step. And so that's why we can stop now at the alkene. Again, the take home is you have an alkyne, H2, and Lindlar's catalyst, you get an alkene. But if you have an alkyne and you do H2 and platinum or palladium, you get the alkane. All right? So, but it turns out this is going to give us the cis, all right? And there's another method that we have for getting the trans. The other method is sodium and ammonia. So your textbook's got a nice mechanism for this. I think it's a great mechanism, and if you have the patience, you'll be better off if you can go and pursue that mechanism and follow the electrons all the way through. But I'm not going to show it to you here, and I'm not going to test you on it. So this is called a dissolving metal reduction. We take a metal and we dissolve it in ammonia, and this reduces to the trans alkene 80%, but we're going to call that majority product, okay? So this is stereoselective for the anti-addition of the two hydrogens. All right, so we've got two ways of making alkenes. One is with Lindlar's catalyst that makes the trans, or rather the cis alkyne, and man, my language is, this makes the cis alkene. The dissolving metal reduction makes the trans alkene, and we can take any of those and go then to the alkane. All right, so think about what those things can do for you and go practice them.